Hello, my dear young ones. Hello there. Am I audible to everyone? Can I get a thumbs in the chat box if I am? Sounds good. Hello there. Am I audible? Am I audible? Alright, so welcome to another marvelous power-packed revision session from GoScore, and we are the fastest growing edtech in GCC, and our main aim is to provide the quality education for all. Hello there, how are you guys doing? I know exams are around the corner and you might be feeling that pressure, but don't worry, we have got you covered. Okay, so in today's session, we are going to discuss about the question paper of 2023. As we already know, we have to solve as many papers as we can because it's for the better preparation for the exams, right? So without wasting any time, let's get into the 2023 paper, and I'm here with the set 1 of 2023. Okay, so if everyone are there, can I get the thumbs up? All right, very good, very good. I can see an active comment box over there. And hello everyone, shall we get started then? Shall we get started with the first question? Okay, so let's grab the book and stay focused throughout the session, and let's make this revision count. Okay, so here we go with the first question that we have. Okay, so this is the first question, and as we already know, we have so many sections, right? In which the section A carries the 1 mark question, the MCQs and the assertion and reason type of question. So let's go ahead with the first question that we have. Alright, section A. In the experimental setup, there is an experimental setup given in the paper, and just clearly observe what are the things or the liquid that we are going to take in this apparatus or the setup. The first thing that I notice is the dilute hydrochloric acid in the test tube. Okay, so the first thing that I'm going to take is the dilute hydrochloric acid in the test tube. Okay, then I have the sodium carbonate along with the hydrochloric acid. So first thing you should know, what is the reaction happens between the sodium carbonate and the dilute hydrochloric acid, and there will be a gas produced, and I'm passing that gas through a liquid X. Now what happens? That is the experimental setup, okay? And you have to find X and what's gonna happen right over there, and it turns milky, and we will do it, okay? So the first thing that you have to understand that what happens if the HCl reacts with, okay? So let me change the color with the pen first, and we will go. Okay, so I'm going to take the HCl and let it react with the calcium carbonate which we had in the test tube, right? So we had calcium carbonate, right? Here, so that's sodium carbonate, okay? Whatever, it's the same reaction, sodium carbonate and the hydrochloric acid. Sodium carbonate is Na2CO3. So Na2CO3 and HCl, definitely we have the carbonate over there, carbon dioxide will be produced. Okay, so let's write the reaction. We have Na and the Cl. It will be giving you NaCl. Of course, we have the carbon dioxide produced right over here. And we have hydrogen and 1 oxygen left, so H2O. Let's balance the chemical equation. Balance the chemical equations are real important. So let's balance the chemical equation right over there. We have 2 Na, so 2 NaCl. And we have 2 Cl right over there, so 2 HCl, and the hydrogen, we got everything covered, right? So that is the balanced chemical equation where the sodium carbonate reacts with HCl. Definitely we will get a gas called as carbon dioxide. And I am going to pass this carbon dioxide through a liquid which is given in the question paper as X. And can anyone tell me what that X has? I'm looking into the comment box. Can anyone tell me what is that X? What is that X? Okay, what is that X? X is nothing but your lime water. What is the formula for the lime water? Lime water, the carbon dioxide, when passed through the lime water is nothing but calcium hydroxide, CaOH2. That is your lime water, right? Lime water, that is your X. Okay, lime water is your X. And when I pass this carbon dioxide through lime water, what I'm gonna get is really simple. I will get the calcium carbonate which is an insoluble precipitate in the water. Okay, along with I will get the water molecule. Okay, along with I'll get the water. Okay, and it's already a balanced chemical equation. And this calcium carbonate right over there is insoluble in the water, which will be giving you a white precipitate or turns the calcium hydroxide or the lime water milky. Okay, so calcium carbonate will be formed, which is insoluble in the water, turns the lime water milky. Okay, now if we pass a carbon dioxide for a long time, okay, suppose we are passing the carbon dioxide for a long time, and we already have the calcium carbonate and the water in the test tube. Along with, I'm gonna pass the carbon dioxide for a long time. Along with, I'm gonna pass the carbon dioxide for a long time. And what I'm gonna get is super easy again. That is calcium hydrogen carbonate. CaHCO3 twice. Okay, calcium hydrogen carbonate, and surprisingly, it is soluble in the water. Hence, the milkiness or the white precipitate disappears. Right? The milkiness disappears if we pass the carbon dioxide for a long time. And these two reactions are quite important because it's asked in every exam. And I cannot discuss the same question in the last paper, I guess. In the one of the revision session, I have discussed the same question. Okay, so that means it's a repeated question, okay, which you have to concentrate on. Okay, so looking into the comment box, is it lagging? Am I audible to everyone? Am I audible to everyone? Is there any trouble? Is there any trouble? Can I get some comments over there? Feels like it's lagging. Is it? Am I? Okay, shall we continue? If there is no such problems, can we continue? Okay, so I hope I'm clear. Voice is clear, ma'am. Okay, fine. Thank you for letting me know that. Now, this is the basic concept of that diagram, okay, of that experimental setup. This is the basic concept. And the thing that you're going to look into the options. These are the 4 options. I know it's a bit lengthy and you guys might be feeling it's too lengthy to read, right? But it's fine. So just 1 mark, right? You will get 1 mark if you do it. So go ahead, okay? So it turns milky due to the carbon dioxide liberated. That's correct, right? The milkiness is formed due to the liberation of the carbon dioxide into the lime water. And in the reaction, and after some time it becomes colorless due to the formation of the calcium carbonate. No. It becomes colorless due to the formation of the calcium hydrogen carbonate. That's the wrong statement. Turns milky due to the formation of the calcium carbonate. Yes, that's correct. Due to the formation of the calcium carbonate, that's correct. And on passing the excess carbon dioxide, it becomes colorless due to the formation of the calcium hydrogen carbonate, which is soluble in the water. That is a correct statement. So that is a correct statement actually. Okay, that's a correct statement. So option B is the right answer. Okay. So option B is the right answer. Done? Shall we get into the next part? Okay. Okay. Now, let's look into the next part. Again, an experimental setup. Let's get into that. The emission of the brown fumes in the given experimental setup is due to. Okay, we have the brown fumes, and what is there inside the test tube? We have lead nitrate in the test tube. So what is the formula for the lead nitrate? I'm looking into the comment box. Okay. Give me a response. What is lead nitrate? What is the formula that you can give for the lead nitrate? Okay. What is the formula that you can give for the lead nitrate? Very good. That is PbNO3 twice. Okay. PbNO3 twice is the lead nitrate. Now, on heating this, On heating this, definitely lead nitrates is undergoing the thermal decomposition. It will undergo the thermal decomposition. It will undergo thermal decomposition. And what do we get? It's really easy. We will get the lead oxide. We will get the lead oxide, that is PbO. And definitely we are going to get the nitrogen dioxide, NO2. And along with, you're going to get the oxygen. So again, balancing is the most important part. So I'm going to put PbO over there and let's put Pb. Okay, and we have 2 to 4 nitrogen over there, so 4 NO2. Okay, I hope it's already balanced. Correct? Okay, that's a balanced chemical equation that you have. That's a chemical equation that you have. Okay, any doubts so far? Any doubts in this? No, no doubts, right? And what is the cause of this brown gas? What is the cause of this brown gas? The brown gas is due to the formation of the nitrogen dioxide. Nitrogen dioxide is the one which is giving you brown fumes. Okay, the brown fumes is definitely due to the formation of the nitrogen dioxide gas. Now let's get into the question back. Okay, so the thermal decomposition of lead nitrate which produces brown fumes of nitrogen dioxide. That's a correct statement, right? That's a correct statement. So without even thinking, we can pick the A. And if you are not confident enough, you can go ahead by reading the next options. Okay, so since we don't have much time, it's already like 15 minutes past. So I'm just letting you go with this and I'm going to go with the next question. Okay. Now, MnO2 and XHCl will be giving you MnCl2 and YH2 and ZCl2. Balance the chemical equation. It's really easy, right? It's really easy. Now, let's get into that. Okay, we have MnCl2. Indicates that we have 2 chlorine atom. Okay, now we have another 2 chlorine atom right over there. Makes it a total of 4 chlorine atoms, right? There are 4 chlorine atoms. On the other side, we have only 1. So let's make it balanced by adding 4 over there. Let's give it a try, okay? Let's give it a try. It's like a trial and the error method, okay? Let's do it, okay? Trust the process, okay? Now we have 4 HCl and we know that 4 hydrogen atoms are there and here we have only 1 water molecule and there are only 2 hydrogen atoms. So in order to make it into 4, I'm going to add 2 over there. So it's 2H2O. Is it balanced? And coming into the Z, chlorine is already balanced, right? So we want only 1 over there. So it's going to be 4, 2, 1. That is option C. Yay, we made it correct. Okay, I hope you are doing all the questions along with me, isn't it? Okay, I hope you are there with me. And that is going to be 4, 2, 1. Any doubts? If not, moving ahead with the next question. The table below has informations regarding pH and the nature, acidic, basic of 4 different solutions. Which one of the options in the table is correct? Okay, we have A, B, C, D. 4 solutions are given and comparing the data is given, you have to pick which is correct one. Okay, and let's go ahead with that. Lemon juice is the first solution that we have, cool. And color of the pH paper is going to be orange, that's again correct. And approximate pH value is about the 3, that's again correct itself. Nature of the solution, basic. Tada, that is incorrect. It's acidic, right? It's acidic. Lemon juice is acidic in nature, not the basic. It's not basic. Milk of magnesia. Color of pH paper is blue, that's correct. And approximate pH value is going to be 10 to 11, that's again correct. And it's basic in nature. Yay, that is the correct one. Now let's go ahead with the next one. Gastric juice, your HCl. Color is going to be red and the approximate pH value is 6. No, it's going to be around 1.5 to 3.5. It's around that range. It's not 6. It's acidic. That's correct. But 6. That will be giving you a wrong answer. Pure water, yellow. No, pure water is neutral. It's green in color. Okay, it's green in color, not yellow in color. 7 and neutral. Okay, that's again incorrect. The only one given right data is for the B, milk of magnesia. Okay, so I hope you got the answer. I hope you got the answer. Correct? Super easy, super easy. Yeah. Okay, so Sad feeling? Why your name is sad feeling? Alright, anyways, it's 421. That's correct. Okay, you got the right answer. Okay, good job. Now getting into the next one. A metal X is used in thermite process. Okay. Now, when X is burned in air, it gives an amphoteric oxide. Amphoteric oxide, you have to remember two oxides for the amphoteric, that is aluminum oxide and the zinc oxide. Okay, and out of aluminum and the zinc, which one is used in thermite process? Definitely aluminum. So let's write the aluminum. It's not there in the question, but just an additional information. If they ask the 2 or 1 mark, what are you going to do? So I'm just giving you an information, okay? So we know that the metal X is nothing but our aluminum, which is used in the thermite process. When burned in the air, okay, oxygen, definitely we are going to get, what's the oxide? What is the oxide of aluminum? Al2O3, that's correct, Al2O3. So let's balance it, 3, let's 2 and 3 and 2 to 4 aluminum. So we will get Al2O3, and this Al2O3 right over there can act as an amphoteric oxide. It's an amphoteric oxide just because it can act as an acid, it can act as a base as well, okay? Or it can react with the acid to form salt and water, or it can react to the base to form the salt and water. So such species are something called as amphoteric oxide, and the Al2O3 is an amphoteric oxide, okay? And aluminum is the one which is used in the thermite process. So coming into the X and Y. So X is nothing but aluminum and Y is your Al2O3. So where is that option? Right over here. So Al and Al2O3. Okay. Done. Able. Very good. You gave the B option without even explaining. Okay. So he didn't let me explain. He already answered it. Very good. Okay. Getting into the next one. Select washing soda from the following. So without thinking twice, you should be able to answer this. Okay. So the thoughts will not hold you back. So it should be thorough for you. Okay. All the formulas of all the salts, you should know this. There's no other way. So it's again Na2CO3 10H2O. Okay, it's Na2CO3 10H2O. Good job, guys. Good job. Okay. Hold on. Okay, let's move ahead with the next question then. This is our next question, okay? So this will be our next question. Okay, so this will be our next question. Consider the structure of 3 cyclic carbon compounds ABC given below and select the correct option from the following. Okay, so these are the 3 options given, that is A, B and C. A, B and C. Just clearly observe this and I will show you the options. Okay, I will show you the options. Just carefully look into the structure. Okay, carefully look into the structure. I'm going to change it within 3, 2 and 1. Here we go with the options. Okay. A and C are the isomers of the hexane and B is a benzene. A is an isomer of the hexane, B is a benzene and C is an isomer of hexane. Just read it. Okay, A is a saturated cyclic hydrocarbon, B and C are the unsaturated cyclic hydrocarbons. A is a cyclohexane and B and C are the isomers of the benzene. What do you think the right answer will be? Again, I'll give you a chance to look into the structures again. And coming into the A, we know that it is a cyclic structure, okay? So which will be having the formula of, let me change the color of the pen, okay? So which will be having the formula of C6H12, okay? And the formula for the hexane, okay, not the cyclic one, just the hexane, it will be C6H14, right? And the isomers are the one which will be having the same molecular formula. Now, do you think they have the same molecular formula? Definitely not. Definitely not. They don't have this. They don't have the same molecular formula. It's entirely different. Okay, say 6H12. It's not. It's not isomer of the hexane. But it is a saturated. It is a saturated cyclic compound. That's correct. It's a saturated hydrocarbonic cyclic compound. And the second one is again an unsaturated cyclic carbon, which we'll be calling as benzene. And this, when we consider these two, they're entirely different. We have like 3 double bonds over there, only 2. They cannot be the isomers, right? And the correct option will be definitely A is a saturated cyclic hydrocarbon. B and C are the unsaturated cyclic carbon, right? That's correct, right? Because both of them have the double bonds. And here it is saturated, these two are unsaturated. That will be giving you the option C again, okay? Now let's get into the next one. Assertion, okay? So assertion, this will be completing our section A part from chemistry, okay? Now assertion, the color of the aqueous solution of copper sulfate turns colorless when a piece of lead is added to it, okay? Now, the color of the aqueous solution of copper sulfate, you should know the formula of the copper sulfate first, okay? The first thing that you're going to do is write down the formula of the copper sulfate, the hydrated copper sulfate. It's nothing but, let me change the color, okay, it is CuSO4 5H2O. So this is the formula that you can give for the hydrated copper sulfate, CuSO4 5H2O, correct? Now, when we heat it, what happens? When we heat it, what happens? It have 5 water of crystallization. On heating, it will be like all the water of crystallization will be like removed from the copper sulfate so that we can write CuSO4 plus 5H2O. Okay, it will become dehydrated and the copper sulfate now have the white color. Okay, now get back into the assertion again. The color of the aqueous solution of copper sulfate turns colorless when the piece of like, oh, oops. They are asking for the decomposition reaction, not the thermal one. Okay, so hold on. Now into the copper sulfate, you're gonna add the lead. Okay, I didn't read the question, my bad. Okay, so lead is added into that. Definitely, it is a displace. Okay, so definitely it's a displacement reaction. Okay, displacement reaction where Pb is more reactive than the copper. Okay, I hope everyone knows the reactivity series, correct? Okay, do everyone remember the reactivity series? Of course, those who remember can easily note this, where the Pb is more reactive than the copper. So displacement reaction takes place and becomes PbSO4 and the copper, and definitely PbSO4 is colorless. Okay, that will be giving you the right answer for the assertion. The color of the aqueous solution of copper sulfate turns colorless when the piece of lead is added to it. Okay, so always remember to read the complete assertion first. Okay, so that's a true statement. Lead is more reactive than the copper and hence displaces the copper from its salt solution. Reason is again correct. And remember, reason is the correct explanation for the assertion that will be falling into the option A. Okay, so if you just write assertion and reason, both of them are correct, and give the correct explanation for the assertion, you will get 1 mark. Okay. So if this clear, can we get into the next question? Here we go with the section B, which is comprising of 2 mark questions. Okay. So here we go with the first one. A compound X, which is prepared from gypsum, okay, has the property of hardening when mixed with a proper quantity of water. Okay, so compound X is prepared from gypsum. What is the formula that you can give for gypsum? What is the formula of gypsum? Definitely that's correct. That is calcium sulfate. Okay, that is calcium sulfate 2H2O is your gypsum. On heating it under 373 Kelvin, you will get calcium sulfate half H2O or calcium sulfate hemihydrate along with 1.5 water molecule. 1.5 water molecule. That calcium sulfate hemihydrate is something you commonly called as plaster of Paris, POP. That's your plaster of Paris. And the chemical name goes like this, the calcium sulfate hemihydrate. Okay, now compound X, we got it. Compound X is nothing but your plaster of Paris. Okay, identify X and write its formula. X is calcium sulfate hemihydrate, plaster of Paris, and the formula goes like that. Select the difference in chemical composition between baking soda and the baking powder. So, shall I erase this? Shall I? Okay, shall I erase this? Okay, good. Baking soda. Okay, what is the formula that you can give for baking soda? What is the formula that you can give for baking soda? We'll write baking soda first. What is the formula for the baking soda? Can I get the answer in the comment box? Can I get the answer in the comment box for the formula of the baking soda? Na2CO3, correct. Okay, it's Na2CO3. Okay, I'm sorry. NaHCO3. So NaHCO3, that's very good, correct. Okay, so baking soda is NaHCO3. Now coming into the baking powder, what might be baking powder now? Okay, what might be baking powder? Okay, what might be baking powder? Quick. What's the basic difference between baking soda and the baking powder that you might be using in the snacks and the cakes, right? You might be using it. Yeah, I have explained this in the last session as well, I guess. Okay, definitely baking soda is NaHCO3 and we know that it is basic in nature and it will be having a bitter taste. If we use the baking soda in the cakes will be a bit bitter and we don't want that, and since the cake is a dessert, we want the sweet thing, right? So in order to neutralize the bitter taste, we are going to add some acid. The acid is going to neutralize the base right over there, correct? So, if we use mild edible acids like the tartaric acid or the citric acid, we can neutralize the effect of bitterness. So, baking powder will be consisting of the baking soda along with tartaric acid or any tartaric acid or any mild edible acids. Okay, so that will be giving you the composition of the baking powder. This is again a repeated question that you can expect in the exam. Okay, if you're done with that, we will move into the next question without wasting time. Here we go, we have an OR question. If you have struggled to answer that question, okay, there is a lifesaver, that is your OR question. Write the balanced chemical equation for the reaction that occurs when blue colored copper sulfate crystals are heated. Okay, so what is the formula for the copper sulfate? The hydrated copper sulfate, that is your CuSO4 5H2O. That's your hydrated copper sulfate solution, which will be having blue color. Now let's heat them up. Okay, on heating, they will lose all the water of crystallization and it will become copper sulfate, CuSO4 plus 5H2O. Okay, copper sulfate, this will be now white in color. Okay, this will be now in white color. Okay, so that is the perfect balanced chemical equation that you can give for the first one. Now, getting into the second one. Sodium hydrogen carbonate is heated during cooking. Sodium hydrogen carbonate is nothing but your baking soda. Okay, let's cook some baking soda, that is NaHCO3. On heating NaHCO3, you are gonna get Na2CO3 along with carbon dioxide and the water. Okay, along with the carbon dioxide and the water, all I'm gonna take is nothing but 2NaHCO3. So definitely this will be the balanced chemical equation, and always remember to write the balanced chemical equation or else you will mess up at the end. Okay, so you will get the low score if you don't write the balanced chemical equation. Okay, so make sure that you always give the balanced chemical equations. Okay, and don't forget to write the heat or the delta sign above the arrow mark. Okay, and if you are not sure about this, there's no option. Okay, you will be having only one or question. There is no 2 or 3 or questions. Okay, it's just only one. You can choose between them. Getting into the next C part. Okay, so actually section B have only one chemistry part, rest is physics and biology. Okay, now coming into the section C, identify the reducing agent in the following reaction. Okay, so in the last class as well, I told you the difference between the reducing agent and the oxidizing agent, as well as oxidation and the reduction. Here we have to check into the reducing agent. If you are pretty confused with that, just check out our last video. Okay, coming into the reducing agent, always remember that reducing agent are the one which is undergoing oxidation. Okay, so reducing agent are the one which is undergoing oxidation, correct? Okay, oxidation is nothing but, what is oxidation? Oxidation is nothing but gain of oxygen. Okay, gain of oxygen or removal of hydrogen. Okay, removal of hydrogen or the gain of oxygen is oxidation. And the species which is undergoing oxidation can be written as the reducing agent. So just check who is undergoing oxidation in the above reactions. Let's go ahead with the first one. Before that, it's time to change the color of the pen. Okay, NH3 is turning into NO. Addition of oxygen, correct? That's an addition of the oxygen, isn't it? So oxygen is getting added up. NH3 into NO. That's definitely oxidation. So NH3 is the one which is undergoing oxidation. So NH3 right over here will be acting as your oxidizing agent. Okay, so I'll circle it neatly. Okay, NH3 is the reducing agent that you have right over here because it is the one which is undergoing oxidation. Okay, now coming in the second one. H2O plus F2 gives HF and the HOF. This is where you will get confused with. Actually, this question will be like the 11th grade topic, and in order to know this, you should actually find the oxidation number and decide about that, and that you'll be learning in the higher grades in the 11th grade. Okay, if you choose science, of course. Okay, so actually in the if you attempt this question and in the answer script there is a word like those who are attempting the second part of 27th question will be awarded with full marks. Okay, so that means if you don't know, if you are confused with anything, just write whatever you know. Okay, so just attend it. Okay, leaving a question without attending is the bad thing that I have ever said. Okay, just attend the question. Just attend the question. Definitely you're gonna get the marks. Okay, so to know this, definitely you want some proofread that. And as of now, since you don't have to learn it, this H2O. For your knowledge, I'm gonna tell you that H2O is turning into HOF, not the HF. Okay, so in the case of the H2O, it's gonna turn into HOF, and this is gonna turn into HF. Okay. So hydrogen is getting added up right over here, and the hydrogen is looser from this, right? So again, this will be acting as a reducing agent because it is the one which is undergoing oxidation. So actually, this is not the way it should be explained, but as of now, in your grade, there is no need of further explanation for that. Okay, anyway. We'll study that in the 11th grade. Okay, now coming into the third one. Fe2O3 and carbon monoxide, definitely Fe2O3 is turning into Fe and the carbon is turning into carbon dioxide where the oxygen is getting added up. So definitely CO is the one which is undergoing oxidation and acting as your reducing agent. Okay, now coming into the fourth one. H2 and the O2, both of them are undergoing oxidation and the reduction. Again, that concept will be learned in the 11th grade. Okay, so it's totally fine. Let's look into the hydrogen. Hydrogen is turning into water molecule and oxygen is getting added up. So H2 is the one which is undergoing oxidation and acting as a reducing agent. Okay, so now define the redox reaction in terms of the gain and the loss of oxygen. Gain and the loss of oxygen. Okay, so is there any queries in the comment box? Like I'm seeing some comments over there. All right, just the answers. Okay, so now define the redox reaction in terms of the gain and the loss of oxygen. We know that gain of oxygen is the oxidation, loss of oxygen is reduction. Okay, if both the oxidation and reduction takes place simultaneously, we call them as the redox reaction. Okay, so redox reaction are the reactions in which both gain and the loss of oxygen takes place. That's how you explain the redox reaction in terms of the loss of oxygen, the gain of oxygen. Or else you can write like gain of oxygen is nothing but oxidation, loss of oxygen is reduction. If both oxidation and reduction takes place simultaneously, we call them as the redox reaction. Okay, so any doubt in that? Any doubt in that? Okay, so we already have the answer. Okay, H2 as F2 is getting reduced. Okay, cell life, good job, good job. Okay. Now let's get into the next question. Suggest one remedial measure each to counteract the change in pH in human beings in the following cases. Counteract. So definitely we have to look into the options. Without looking into the option, how are we going to answer that? Production of too much acid in the stomach during indigestion. Okay. Excess of acid will be produced. Okay, in order to counteract that, in order to neutralize that, that's a neutralization reaction. Definitely we require the base. Now our savior, the base comes into act or the play. Okay, so we have to like eat some base or have some base called as antacid. That's a perfect choice that you have. Antacid. So like intake some antacid. It's a base and the acid together, they just neutralize the reaction. They just neutralize the excess of acid that is produced in the stomach, okay? And we will feel the relief, okay? Antacid will work. Now coming to the second one. Stung by honeybee and the nettle leaves. Okay, so, the honeybee and the nettle leaf, both of them will be injecting the formic acid into the skin, okay? Formic acid or the methanoic acid. Okay, in order to neutralize that, again, we want what? The base. Okay, so what is the base that we can use in such conditions? The mild base. Okay, don't use the strong base and burn your hand. Don't do that. Just mild bases. Okay, mild bases like you can use this baking soda. If you want, baking soda is a mild base. And then in the case of the nettle leaf, this like I just amused about this thing. It's really cool. Okay, so just beside the nettle leaf, you can find another plant called as dog plant. Okay, D-O-C-K, dog plant. And that dog plant, if it's just stung by a nettle leaf, just take that dog plant and just rub it over there. You can like just get a relief from it. Okay, so if you're just confused with the plants, don't do that. Okay, you can use the baking soda, whatever it is, and don't use any other plants other than the dog plant. And if you don't know the plant, which plant does it, like there will be a lot of plants, right? If you are not able to distinguish between the dog plant and any other plants, don't go for it. Okay, if you are able to like identify the dog plant, that's a good choice that you have right over there. Okay, that can save your life. Now, fresh milk has pH of 6. Okay, cool. When it changes into curd, it's gonna change into curd. Will its pH increase or decrease? What do you think? Increase or decrease? Okay, so increase or decrease? It's gonna increase or decrease. And when I was in the other grades, when I ask increases or decreases, they will be like creases, and all together, all the class together will be just shouting out like creases, and I will not be able to understand increase or decreases. What are they be shouting at? So don't be like that. It's chat box, of course, increases or decreases. That's the only two options that you have, not creases altogether. So definitely it's gonna decrease the pH. Okay, so like the pH will be decreasing. It becomes more acidic, right? Due to the formation of like the lactic acid, the curd is more acidic than the milk. Okay, so the curd, due to the presence of the lactic acid, it will be more acidic than the milk. Hence, the pH decreases. You know the pH, right? I hope you know that. If the pH is equal to 7, that is neutral. If the pH is lesser than 7, if the pH are lesser than 7, that's going to be acidic. Okay, so as we get into the lower value, more acidic character will be seen. And if the pH is greater than 7, and it will be basic in nature. Okay, I hope you know this basic idea about the pH, correct? Okay, now, letting into the next one. Getting into the next one, section D. Section D is of 4 marks. Okay, so this is the passage. This is the it's a 5-mark question. I'm sorry, it's a 5-mark question. And this is the explanation where you have to find ABC. Okay, let's get right to this. A saturated organic compound A belongs to the homologous series of the alcohol. Okay, there is an A belongs to the homologous series of alcohol. Definitely it's an alcohol. Okay, understood. On heating A with a concentrated sulfuric acid. Okay, alcohol in concentrated sulfuric acid. Dehydration reaction, water molecule will be eliminated. It forms an unsaturated compound B with a molecular formula 28. Okay, this is our loop point. Okay, that's a loop point 28U. Okay, we know that the water molecule will be eliminated, right? And 28U, how many carbon atoms should be there? Okay, with the 28, how many carbon atoms should be there? Of course, 2, right? Of course, 2 carbon atoms, which will be giving you the 24 unit mass, because one carbon is 12, another carbon is 12, like the total together 24. And we need 4 more hydrogen atoms. So it's definitely C2H4. C2H4, but looking into the equation itself, we can understand that it's an alkene. It is an alkene with the ENA. And the formula is gonna be this. CH2 and the CH2. So this is the product. Okay, this is the product that we got by heating A, okay, by heating A along with the concentrated sulfuric acid. So I'm just erasing it, and or shall I write in the other page? That will be better, right? So we'll just write in the other page. Okay, so we got CH2 double bond CH2 as a product along with the water molecule, just because we are adding the sulfuric acid. Okay, we are going to add the concentrated sulfuric acid, right? Concentrated H2SO4. Okay, so what might be the alcohol on the other side? What might be the alcohol on the other side? Huh? Okay, so the other is gonna be CH3, CH2, OH, isn't it? Why the comment box is so weird? What is that? What are you doing in the chat box? Okay, stay focused on the studies. Okay, we will just do the chat later. Okay, stay focused. Okay, now CH3, CH2, OH, concentrated H2SO4, you are gonna get, what is the name of this? Eth, just because 2 carbon atom, double bond, and the name with the ENE, ethene. 2 carbon atoms, eth, 2 carbon atom, eth. Then we have what? OH, alcohol, and the name with the OL. So ethanol. Okay, so ethanol and the ethene. What is the next question? On heating a concentrated sulfuric acid at 443 Kelvin, we got the molecular 28. The compound B, on addition of 1 mole of hydrogen in the presence of the nickel, changes to a saturated hydrocarbon. See, to the B, I'm going to add 1 mole of hydrogen in the presence of the nickel. This is A, and this is B. Okay, and what I'm going to do to the B? I'm going to add the hydrogen in the presence of the nickel. So CH2, double bond CH2. Into this, I'm going to add what? I'm going to add the hydrogen. I'm going to add the hydrogen in the presence of the nickel. Definitely hydrogen will be getting added up, and I will get the saturated hydrocarbon where the double bond breaks into a single bond. So I will get CH3, single bond CH3, where one hydrogen goes to this carbon atom, another hydrogen atom goes to this carbon atom. Simple. Okay, that is really simple. That was your hydrocarbon C. This is your C. What is the name that you can give for that? Eth, and single bond ANE, and that is your C. Oh, we didn't make the question yet, right? Oh, this is the identify ABC. Identify ABC. You know that, right? ABC, we already identified it. Okay. Now, write the chemical equation showing the conversion of A into B. A into B, conversion. That will be giving you the answer for the second. What will happen to compound C undergo combustion? What was compound C? Oh, this was compound C. When does compound C undergo combustion? CH3CH3. Can I just write it as C2H6? C2H6, one of the same. C2H6, CH3CH3. Okay. And combustion is nothing but reacting in the presence of oxygen to form the carbon dioxide and the water. So reacting with oxygen to form carbon dioxide, water along with a large amount of heat energy. Balancing is the real important part. How many carbon atoms? 2 carbon atoms, so 2 CO3. How many hydrogen atoms? 6 hydrogen atoms, so 3 H2. Okay, so 6 hydrogen atoms. Now let's balance the oxygen atom that is left right over here. 2 2s are 4 plus 3 7. Now we have already 2 over there, so a simple trick, 7 by 2. 2 and 2 get cancelled, 7 oxygen. Balanced. Okay, now. State one industrial application of the hydrogenation reaction. Hydrogenation reaction. Can you just let me know one of the uses for the industrial preparation? What is happening in the chat box, guys? All right. So just tell me an industrial application. Don't you remember? With some vegetable oil converting into the fats. Remember? Okay, so industrial application goes like that. We have the vegetable oil, the conversion of vegetable oil into the fat. Okay, fat, that is one of the application for the hydrogenation. Name the products formed when compound A reacts with the sodium. What is compound A? That is compound A, CH3CH2OH is a compound A reacting with the sodium. Let's write it down. Compound A was ethanol, CH3CH2OH. Okay, let it treat with the sodium. Definitely we are going to get sodium ethoxide, that is CH3CH2O. Instead of H, you will get Na. And the hydrogen will be liberated from that, and hydrogen is always diatomic molecule, H2. Don't leave it as H over there, you will lose the marks. Okay, so H2 in order to balance 2 C3COH and the 2 Na and the 2 CH3CH2ONA. This is your sodium ethoxide. I'm just writing Na. Okay, this is sodium. Sodium ethoxide and hydrogen are the. Oh, we have to only write the name. Simple, right? So we can just write the name along with the reaction. Okay, let's impress the examiner. Okay, if you're done with that, let's go ahead with our question. Oh, you have the our question. With the help of the diagram, show the formation of the micelle when soap is applied on oily dirt. Don't think that this is just for the 5 marks. This is the 3-mark question, and another 2 marks lies right over here. Okay. Now getting into the help of the diagram, formation of the micelle. Okay, getting into the micelle. Okay, before getting into the micelle, you should really understand the structure of the soap molecule. Structure of the soap molecule just lies like this. This is the structure of the soap molecule. Okay, structure of the soap molecule. And this is nothing but your hydrophobic tail. Okay, this is nothing but your hydrophobic tail, which is nothing but your water repellent. Okay, it's water repellent. You don't like the water. Okay, so you don't like the water, but it loves the oil. Okay, now coming into the head, this is your hydrophilic. Okay, which is in love with the water. Hydrophilic head. Okay, so which loves the water attracting species. Okay, so hydrophobic, phobia is fear, right? Hydrophobic, don't love the water. Hydro is water. Hydrophobic as a fear towards the water. So definitely it is like repelled from the water. And it loves the oil, by the way. Now coming into the head part is hydrophobic head. Okay. Now, like as you have understood this, I'm just gonna erase it. Or can we just make it into smaller? Can we do that? Okay, here we go. Let's make it the smaller one. Okay, I'm just keeping it right over here. Okay, done? Okay, so I hope that is visible. Now, coming into the next part. Okay, so when we mix the soap molecule in the water, and the cloth will be having the oil content in that. Okay, just suppose, let's draw the oil droplet. Okay, suppose this is your oil droplet. Suppose this is your oil droplet. And we know that tail is the one which loves the oil, right? It don't love the water, but it loves the oil, right? So the tail, the soap molecule will arrange themselves in such a way that tail will be protruded inwards, like inside. Okay, so it's gonna be just like this, and the head will be protruded out because it don't love the oil, but it loves the water. Okay. Now, so all the soap molecules will come and form a shape like this. It will rearrange themselves in such a way that the head will be protruded out and the tail will be dissolved in the oil. Okay, so draw it neatly, okay? It's not only this, it's actually a three-dimensional structure, okay? Now, what happens is really cool, and the name of this thing is micelle, okay? They will be forming micelle, that's what you have to show, okay? This is the formation of the micelle, okay? This is the formation of the micelle. And when we just wash it, what this micelle will do? Micelle will take the oil from here and just goes with the water. So we can remove the oil droplets from the cloth. Okay. So actually by explaining this, you will get 3 marks. Okay, but you have to explain everything. That's the main important part. Okay. So you will get the 3 marks. Is everything clear? Do anyone have any doubts? The comment box says something else. Okay. Okay. Any doubts so far? Nothing. Nothing. Okay, we'll go with the next part of this. Okay, so that will be giving you 3 marks and the other 2 marks lies over here. Okay, so take 2 test tube X and Y. Okay, I'm going to take 2 test tube X and the test tube Y. Okay, test tube X and Y. My test tubes are not good looking. Okay, anyway, they are the test tubes. Okay, now add few drops of soap. So with 10 ml of the hot water in each, okay, in each of the following, I have hot water. Do you have any idea what in the hot water? Hot water will be having Mg2 plus and the Ca2 plus ions inside that. Okay, always remember the hot water have the Mg2 plus and Ca2 plus ions inside that. Okay, done. Now what? In the test tube X, this is the test tube X, you're going to add the soap solution. Okay, what you're going to add is nothing but the soap solution. Okay, where should I write? Here, I'll write here, okay. Okay, into the X, you're going to add the soap solution. And into the Y, which pen should I take? You go with the yellow. Okay, so into this, I'm going to add what? Detergent solution. I'm going to add the detergent. Okay, so X soap solution, Y detergent. Okay, now let's read it. In which test tube the formation of the foam will be more? So here we have to really understand one thing, that in the hard water, we have Mg2 plus and Ca2 plus ion. And the soap solution, we know the molecule, right, which will be having the Na plus ion. And the soap molecule will react with the ions present in the hard water and form an insoluble substance called as scum. Okay, when soap molecule react with the hard water, react with the the Mg2 plus or Ca2 plus in the hard water, they will be giving you, they'll react together and they will be giving you an insoluble precipitate called as scum. Okay, insoluble precipitate called as scum. So there is no much soap left over to make the foam, right? There's no much soap left because all of them are reacting with Mg2 plus and Ca2 plus to form the scum. So there will be a formation of the less foam in the soap solution, that is in the test tube X. In the case of the Y, detergent, there is no such problem with the detergent. Detergent will not react with Mg2 plus and Ca2 plus to form the scum. Okay, there is no such reaction taking place in the case of the detergent. So all the detergent is available to form the foam, right? So test tube, let me change the color. Test tube Y will be having more foam and explain these reasons. Okay, in which test tube occurred a solid precipitate called as scum will be produced. That is definitely in the X because it's the soap molecule. Soap molecule react with Mg2 plus or Ca2 plus in the solution to form the scum. Done? It's an easy question. If you write the micelle formation and these two, you'll get 5 marks. Or else you can just choose the other options that you have. Okay? Now that's about the 5 mark question. Getting into the section E. Almost all metal combine with oxygen to form the metal oxide. Metal oxides are generally basic in nature. Some metal oxides show both basic and acidic behavior. They are called as the amphoteric oxides. Different metals show different reactivity towards oxygen. Some reacts vigorously while some do not react at all. This is just the passage given. And the questions are here. What happens when copper is heated in air? Okay, give the equation for the reaction involved. Okay, so copper is nothing but Cu. For that we have to change the color of the pen. Copper is Cu. Okay, copper is heated in the air. So definitely there might be some oxygen atoms. So definitely we are going to get the copper oxide which is black in color, right? Balance it 2 oxygen. 2 copper oxide, 2 copper, 2 copper. Balance the chemical equation that will be giving you A. Okay, what happens when copper is heated into air? It will get the copper oxide, which is black in color. Okay, why are some metal oxide categorized as amphoteric? Already explained. Because they can act as the acid, they can act as a base, and they can form the salt and water. Give one example. Okay, so you can either write Al2O3 or zinc oxide. Okay, so where you should know the reaction of Al2O3 with NaOH and the HCl or whatever it is, zinc oxide. I have given a detailed explanation of this in the other classes. Check it out. Now, okay, they are only asking for the example. Okay, where you can just give this example. Complete the following equation. We'll complete it here itself. Okay, Na2 and H2. Na2O and H2. Really simple. We will get NaOH. We'll get NaOH. Let's balance it. 2 Na, 2 H2, 2. Okay, so balance. L2O3 and NaOH, we will get sodium aluminate. What is the formula of the sodium aluminate? NaAlO2. That is sodium aluminate. Okay, Al2O3 along with what? Salt and the water. Definitely it's a base. Al2O3 is acting as the acid. Salt and the water will be produced H2O. Okay, is it balanced? No, you have to add a 2 over there. Did I just erase it? So 2 NaAlO2 and the oxygen, 3 oxygen and 3, 5, 4, 5, balanced. Okay, balanced chemical equation. Any doubt in this? No. Alright, well, let's get into the another one. C part, okay. On burning sulfur, okay, actually, C, okay, this is an OR question, okay. So this will be having 2 marks. And if you are not comfortable with completing the equation, you have an OR part right over here, which is comprising of 2 marks, okay. Now let's do it. Shall we? Okay. On burning the sulfur in the oxygen is a colorless gas produced. Okay, sulfur in the oxygen. Sulfur in the oxygen. A colorless gas is produced, which we will be calling as sulfur dioxide. Write the chemical equation for the reaction. Okay. Name the gas produced. It is sulfur. Sulfur dioxide. Okay. State the nature of the gas. Always remember that non-metallic oxides are acidic. Hello? Hello? Am I audible? Hello there. Am I audible? Yes, am I? Video is post, but you can hear my voice. Okay. Anyway, that's just the last question, right? So I'll just explain it and I'll wind up the session, okay? So, okay, fine. So there is no like color change in the dry litmus paper, okay? There's no color change. And we know that sulfur dioxide is a gas. Sulfur dioxide is a gas. And it should be like reacting in the presence of the moisture. Then only it will like the litmus paper, the color change will be happen. So if there is no moisture content, both of them are dry, so there is no such a color change in the litmus paper. There's no color change, okay? So if it was the wet litmus paper, the blue litmus paper will turn red because it's an acid, okay? That's it. I just came to like tell this, and that's all about our questions that will be completing our set 1 of 2023 paper, okay? And thank you so much for just listening to me, and I'll meet you up with the next paper. And